Hello, students. Good morning. I hope you all are doing very well. Today's lesson is about reflections. An objective is to describe and represent the position of a shape under reflection. First, we're going to look at the meaning of reflection. Reflection of an object is the flip of that object over a line called the line of reflection. This line of reflection is usually referred to as the mirror line. So simply put, reflection is the flipping of an object about a mirror line without changing its size or shape. So an object is flipped across a line of reflection to create the image, just as you can see here. So before the reflection, we have the object. So each point of the image is the same distance from the line as the object is, just that we have it on the opposite side of the line. Mirror symmetry means reflection. The object is reflected in the mirror to give the image. As you can see, we have the original shape on the right hand side, which is the object, and we have the reflected shape on the left hand side, which is the image. The mirror line is what you have, the broken line just right at the middle. The mirror line is where you place the mirror. The diagram shows an L shape reflected in a mirror. So you can use the mirror line to draw the reflection like this. Okay, so you have the object and the image, and the mirror line is where you place the mirror. So let's look at how we can reflect this shape in the mirror line shown. So we have the original shape, which is the object. When you flip it over the mirror line, you would get this. This is the reflected shape. Now you have to make sure that the reflected shape is the same distance from the mirror line as the original shape. The original shape is 3 squares from the mirror line. Also, the reflected shape is 3 squares from the mirror line. Let's take a look at another example. So you have the original shape, which is the object, being reflected over the mirror line. So you flip it over and you have this. So you also make sure that the reflected shape is the same distance from the mirror line as the original shape. As you would see, you have 3 squares from the mirror line for both the original shape and the reflected shape. All right, so that's it. Here's another one. So want to reflect the object shape in the mirror line shown. So we have a triangle, that's the object. So if you reflect in the mirror line, you get something like this. We discover that the two vertices are 1 square away from the mirror line, and the other vertex is just 4 squares away from the mirror line. So the same distance from the mirror line for the object and the image. So this is what I mean. We have the object shape in the mirror line shown to give the image, all right? And for the object, we have 3 vertices, A, B, and C. A is 5 squares from the mirror line, as you can see. The same also with the image. B is 2 squares from the mirror line. The same for the image. And C is 2 squares from the mirror line. It's the same for the image as well. Here's another one. We have an object which happens to be a rectangle with vertices A, B, C, and D. If you take a closer look at it, you discover that A is 4 squares from the mirror line. If you count the boxes we have, the squares we have to the mirror line, 1, 2, 3, 4. A is 4 squares from the mirror line. Also, A prime is 4 squares from the mirror line, which is the image. You can see that you have the same distance for the original shape to the mirror line and also the reflected shape to the mirror line. B is 4 squares from the mirror line as well, and B prime is 4 squares from the mirror line, which is the image. C is 2 squares from the mirror line, 1, 2, and also C prime is 2 squares from the mirror line. D is 2 squares from the mirror line, and D prime is 2 squares from the mirror line. So whenever you're given a shape, you can do well to label the vertices so you can count for the object to the mirror line. and you count also for the image to the mirror line, you should have the same distance. I need to say at this point that line of reflection can be vertical or horizontal. If you take a look at the few examples we took in the previous slides, you discover that most of them are vertical reflection, meaning that the mirror line is on the y-axis. So what that simply means is that the line of reflection do not have to be vertical all the time. They can also be horizontal, as you're going to see in the next slide. But let's take a look at this shape. You want to reflect in a vertical line. That is a vertical reflection. Now, if you look at the shape, you discover that the reflected shape is the same distance from the mirror line as the original shape. Okay. Now look at this shape also. We want to reflect in a horizontal line. You have it, you have the mirror line on the x-axis. So we want to reflect in a horizontal line. So we have the object as shown, and here's the image. So I want to reflect this shape in a horizontal line. That's a horizontal reflection. So you take the vertices Q, R, S, and T. Q is 5 squares from the mirror line. If you count it, you have 5 squares from the mirror line. So you also expect that Q prime will be 5 squares from the mirror line. Okay, R is 3 squares from the mirror line. Also, R prime is 3 squares from the mirror line. S is 1 square from the mirror line. S prime is 1 square from the mirror line. So you mark the vertices for the image with a point so you can draw your image. Then T is 3 squares from the mirror line, as well as T prime, which is 3 squares from the mirror line. Then when you're done, you connect the point so you have your image on the other side. So this is a good example of horizontal reflection. So I want to describe the reflection in this diagram. Okay, you have the object on your right hand side, A, B, and C with 3 vertices, and you have the image also on your left hand side being reflected over a mirror line. Okay, so the triangle ABC, which is the image, is the reflection of triangle ABC in the mirror line, as you can see. So you notice that the line joining A, which is the object, to A slash, which is the image, is at right angle to the mirror line. And the 3 points on the object, that is the 3 vertices on the object and the image, are the same distance from the mirror line. We talked about this before in the first 3 slides. So let's take a look at this. It says reflect the rectangle in the 2 mirror lines. We have 2 mirror lines, the vertical line and the horizontal line. So first, reflect the rectangle in the vertical mirror line. This is what you get. Okay, then you reflect both rectangles in the horizontal mirror lines, that is both rectangles above the mirror line. We have 2 rectangles above the mirror line, then we have this. Okay, all right, so let me just run through the lesson giving a short summary. Okay, a reflection of an object is the flip of that object over a line called the line of reflection. Take note, the line of reflection is usually referred to as the mirror line. And when you flip an object about a line, you do not change the size or the shape of that object. I also said that the object is reflected in the mirror line to give the image. So before the reflection, we have the object. So the mirror line becomes a line of symmetry. Note that the image is the same distance from the mirror line as the object is. So each point of the image is the same distance from the line as the object is, just that we have it on the opposite side of the line. Thank you for listening.